Hello, we are here to present our BE project, Nirs, a novel hybrid mechanism for detection of wormhole attacks in wireless sensor networks. So, what is a wormhole? A wormhole is an out-of-band connection between two nodes using wired or wireless links. In a wormhole attack, two conniving sensor nodes tunnel control and data packets between each other. Generally, this type of attack is launched by two or more malicious nodes having a private channel called a tunnel between them. Since wormhole attack creates false entries in the routing table, detection of wormhole links is a major challenge in the current scenario. Hence, we have attempted to detect such wormhole links in a wireless sensor networks using a novel-based hybrid method, which we have named it as NRIS, Neighbor Ratio Isolation.
So here we are defining the potential threats in different sectors. So the primary goal for our project is to detect the wormhole links in the networks that we are using. In application diagram. So the project is basically divided into two phases, three stages. In phase one, we consist of stage one, where we analyze the performance metrics. In phase two, we have two stages. The stage two consists of the NRT, that is the neighbor ratio threshold, and the next stage is the isolation of the suspicious nodes.
Yeah, so this we usually normally we use the two algorithmic approaches in our project. The first algorithm is the NRT algorithm, that is the neighbor ratio threshold, which is taken from the base paper. What it does is it uses the concept of neighbor ratio and isolates or shortlists certain nodes from the whole set of nodes which are probable to be malicious. Next. This is the second algorithm. This is the NRIS algorithm, or the isolation algorithm which we have designed using the concept of the maximum applicability towards the performance metrics. What this algorithm does is it uses the pairs of each pairs of nodes which are generated in the suspicious node set, and it isolates those pairs from the overall network, and then we check in this algorithm whether the remaining network consists of wormhole characteristics or not. If it does, if it still does, then we can conclude that the whole then the isolated pair is not malicious. If the wormhole character disappears, then we conclude that the isolated pair is malicious.
Well, so these are the system specifications for our project. The operating system on which the whole thing is based is Linux. We have implemented the whole algorithm in C++ and Python. The development environment which we've used is NS3. Well, okay, so the input for our whole algorithm is basically just the routing table which is generated after the simulation, and the performance metrics uh, data file which is generated again after the integration of two stages. So these are the basic trends. This is how the trend of the results should be followed. Like the average throughput before the attack is generally normal, or let's say on the baseline, and after the attack is uh, after the attack occurs in the network, the throughput decreases. Same happens for the packet delivery ratio, and it is the inverse in the case of end-to-end delay. So these are how the results generated, where we can see the graph for average throughput, packet delivery ratio, and end-to-end delay.
At the end of this, what do we get? We've obtained the correct malicious node pair by analyzing the performance parameters. One of the features of this process that we have designed is implementing the algorithm using minimum resources. Now let's go through the demo in detail.
Okay, so we basically run our the first script where the attack state is enabled and a result matrix is generated. After this part, we run the script where the attack is disabled, and again the result matrix is generated, which running these two files gives us a basic data for on which we can work, and on base of this data we determine our next implemented algorithm. These two files are integrated in the next stages. Stage 2 and the third stage is integrated in one single file, only for the clean code purpose. So this is how the result matrix looks in the running state. This is again the graph which was shown earlier. Nothing fancy. So this is the suspicious node set which is generated after running our first algorithm, which was taken from our base paper. And our algorithm basically searches for alternate possible link, and then it isolates the specific node pairs. Because if there is no alternate possible link, then there is no point in isolating the specific node pairs. And after the isolation, we get our final suspicious node set, which is malicious. Thank you.